The Extraordinary Secrets of Einstein's Brain, A Journey into Genius. Albert Einstein, one of the most celebrated minds in history, revolutionized human understanding of the universe with his groundbreaking theories. But what made his brain so unique? For decades, scientists and researchers have sought to uncover the secrets of Einstein's unparalleled intellect. When his brain was preserved for study after his death in 1955, it sparked a wave of fascination and mystery. The findings revealed startling insights about the physical structure of his brain, its unique features, and how they might have contributed to his genius. From abnormal anatomical traits to surprising revelations in its microscopic architecture, Einstein's brain was indeed different in ways that continue to astonish and challenge modern neuroscience. One of the most striking differences in Einstein's brain was the structure of his parietal lobes, which are critical for mathematical reasoning, spatial understanding, and visualization. Studies revealed that Einstein's parietal lobes were unusually large and had an extraordinary arrangement of ridges and grooves known as gyri and sulci. Compared to an average human brain, his inferior parietal lobule was highly developed. This region of the brain is associated with abstract thinking, problem-solving, and the ability to conceptualize complex ideas. The absence of a groove called the Sylvian fissure in this part of his brain allowed for enhanced connectivity between neurons, potentially enabling faster and more efficient processing of information. This anatomical anomaly could explain how Einstein was able to visualize and conceive complex theories like relativity, often describing his thought process as visual imagination rather than verbal reasoning. Moreover, Einstein's corpus callosum, the bundle of nerve fibers connecting the two hemispheres of the brain, was thicker than average. This feature suggests that Einstein had an unusually high degree of communication between the left and right hemispheres of his brain. The left hemisphere, typically associated with logic, mathematics, and language, worked in concert with the right hemisphere, which governs creativity, imagination, and spatial reasoning. Such enhanced interhemispheric communication might have been key to Einstein's unique ability to combine rigorous scientific analysis with creative and intuitive leaps, a hallmark of his genius. At the microscopic level, Einstein's brain also exhibited some astonishing traits. Neurologist Marion Diamond's research in the 1980s revealed that Einstein's brain had an unusually high number of glial cells in certain areas. Glial cells are often referred to as the brain's support cells because they provide nutrients and maintain the health of neurons. However, they also play a significant role in enhancing synaptic function and supporting cognitive activity. The higher density of glial cells in Einstein's brain suggests that his neurons were exceptionally well supported, allowing for greater mental endurance and efficiency. This could have contributed to his ability to focus deeply on complex problems for extended periods, a characteristic that defined his work ethic and intellectual pursuits. Another fascinating discovery was the asymmetry in Einstein's brain. Researchers found that his right and left hemispheres were not perfectly symmetrical, a trait that is somewhat unusual in humans. This asymmetry is thought to have played a role in his ability to think outside the box and approach problems from unconventional angles. The combination of anatomical abnormalities and enhanced neural connectivity likely enabled Einstein to process information in ways that were fundamentally different from most people. Additionally, Einstein's brain was slightly smaller than average in terms of mass and volume, which initially puzzled scientists. However, this smaller size was offset by the increased density of neurons and the unique organization of his cortical structures. The tightly packed neurons allowed for shorter and more efficient neural pathways, reducing the time it took for signals to travel between different parts of the brain. This efficiency could have been a factor in Einstein's rapid problem-solving abilities and his capacity to juggle multiple abstract concepts simultaneously. One of the most surprising and controversial aspects of Einstein's brain research came from its preservation and subsequent dissection. After Einstein's death, his brain was removed without the permission of his family by pathologist Thomas Harvey. Harvey preserved the brain by dividing it into 240 blocks and slicing it into thousands of thin sections for microscopic study. Over the years, samples of Einstein's brain were sent to researchers worldwide, leading to a fragmented and uneven analysis of its structure and function. This unconventional handling of Einstein's brain has raised ethical questions, but it also allowed for groundbreaking discoveries that might not have been possible otherwise. A key secret that emerged from these studies is Einstein's unique approach to thinking and problem solving, which might have been influenced by his brain's unusual structure. Einstein himself often emphasized the importance of imagination over knowledge, famously stating, "Imagination is more important than knowledge." For knowledge is limited, whereas imagination encircles the world. This philosophy is mirrored in the physical traits of his brain, which combined heightened connectivity, asymmetry, and efficiency to create a perfect storm for innovation and creativity. His ability to visualize abstract concepts, such as imagining himself riding a beam of light, a thought experiment that ultimately led to his theory of special relativity, was deeply rooted in his brain's distinctive features. Another intriguing detail is the role of Einstein's upbringing and environment in shaping his intellect. While much of the focus has been on the anatomical features of his brain, it's important to recognize that Einstein's childhood curiosity, love of music, and exposure to a rich intellectual environment likely played a significant role in developing his genius. For instance, Einstein was an accomplished violinist and often turned to music as a source of inspiration and relaxation. Neuroscientific research has shown that playing a musical instrument enhances neural plasticity and strengthens connections between brain regions, particularly those involved in creativity and problem solving. This intersection of nature and nurture likely amplified the unique physiological advantages of Einstein's brain. Despite all these revelations, Einstein's brain remains an enigma. While the anatomical differences provide some clues, they cannot fully explain the depth of his genius. Intelligence and creativity are complex phenomena influenced by a combination of biology, environment, and personal experiences. Einstein's relentless curiosity, rebellious spirit, and unyielding commitment to understanding the mysteries of the universe were as much a part of his brilliance as the physical structure of his brain. In the end, the study of Einstein's brain has taught us more about the human mind than about Einstein himself. It has revealed how the interplay of unique anatomical traits, enhanced neural connectivity, and environmental factors can shape extraordinary intellects. However, it has also shown us that genius cannot be reduced to a single set of physical characteristics. Einstein's genius was as much about how he used his brain as it was about the brain itself, a reminder that the true power of the human mind lies not just in its biology, but in its boundless capacity for wonder, imagination, and discovery. Thank you for being with us. If you found this video enjoyable, please hit like and subscribe for more amazing videos. Don't forget to turn on the notification bell for new updates. We truly appreciate your continued support.